Hello, I'm Logic Bunny, and come with me down the rabbit hole of knowledge.
Ever gaze up at the night sky and notice our home, Earth, shimmering like a bright blue gem against the inky blackness? Then, your eyes might drift to our neighbor, Mars, appearing as a distinct, rusty red beacon. It makes you wonder, doesn't it, why the striking difference in their cosmic attire? It's certainly not as simple as someone deciding to paint one planet red and the other blue. Think about it like this. Have you ever had a favorite t-shirt that, after a summer of fun and sunshine, starts to look a little faded, a little less vibrant? That change, that shift in color, isn't some kind of magic. It's actually chemistry at play, a subtle transformation caused by the very elements around it. Planets, in their own grand, celestial way, are a lot like that t-shirt. They have their own unique chemistry sets that determine their colors, and we're about to explore them. Today, we're embarking on a journey to uncover the secrets behind Mars' signature rusty hue. But we won't stop there. We'll zoom out, looking at how other planets in our solar system, and perhaps beyond, have acquired their own distinct and fascinating shades. Prepare to be amazed, because the science behind these planetary colors is surprisingly simple, yet incredibly powerful. Let's dive into the logic of the cosmos and discover what truly paints our universe. The secret behind Mars' famous red appearance is surprisingly simple: iron. Imagine the dust that covers the Martian surface. This dust is rich in iron, and when iron rusts, it turns a familiar reddish-brown color, much like an old bike left out in the rain. That's exactly what's happening on Mars. But how did Mars become so thoroughly rusted? While Earth has abundant iron, water, and a protective atmosphere, Mars lost most of its atmosphere and water billions of years ago. This allowed the available oxygen in its thin air to freely react with the iron minerals in the rock's overeons. This continuous reaction is what gives Mars its distinctive, widespread rusty hue. You can actually witness a similar chemical process if you mix iron powder, like the kind you might find in steel wool, with vinegar, which is an acid. You'll see a reaction. The bubbling you observe is the iron reacting with oxygen. It's a much faster version of what happened on Mars over millions of years, giving us a tangible example of this planetary coloring. When you try this experiment, remember safety is key. Always perform it in a well-ventilated area and try not to inhale the fine iron powder. Vinegar itself is safe, but it's always best to have an adult supervise your scientific adventures. Now, thinking about the colors we see in rocks and planets, what other elements do you suspect might be responsible for giving them their unique shades? Share your thoughts in the comments below. Your curiosity might just inspire our next exploration. Our universe is a vast canvas, and the planets are its breathtaking artwork, each painted with a unique palette. Beyond Mars' familiar red, we find a dazzling array of colors, from the swirling, banded storms of Jupiter to the uniformly bright, cloudy face of Venus. These vibrant hues aren't just for show. They are whispers of the planet's hidden stories, revealing clues about their composition and the very nature of their atmospheres. Take Jupiter, for instance. Its mesmerizing bands of color are not solid ground, but rather colossal clouds made of different chemical compounds. High up, we find fluffy white clouds of ammonia crystals. Deeper down, there are clouds tinged with reds and browns from ammonium hydrosulfide. And in between, water ice contributes to paler yellow shades. When these chemicals are churned and mixed by Jupiter's incredibly powerful planet-wide storms, they create the spectacular, striped appearance we observe. Then there's Venus, often called Earth's sister planet due to its similar size, but oh so different in reality. Venus is completely enshrouded in a thick, dense atmosphere, but its color comes from clouds made not of water, but of sulfuric acid droplets. This highly reflective chemical gives Venus its brilliant, yellowish-white glow, and it also plays a crucial role in making Venus Venus the hottest planet in our solar system by trapping the sun's heat. You can get a little taste of how these planetary colors might blend by trying a simple experiment at home. Grab a few different food colorings and some water. As you mix them, observe how the colors combine and create entirely new shades. It's a small, visual representation of how different chemical compounds, swirling together in the vast atmospheres of planets, can result in the unique and stunning colors that paint our celestial neighbors. Which planet's color do you find most surprising or intriguing? Let us know in the comments below. Your curiosity fuels our exploration, and we'll see if we can unravel the colorful chemistry behind your favorite celestial sights. Have you ever stopped to think about how we actually see color? It's a fascinating dance between light and the objects around us. What we perceive as color is really about what happens when light, like sunlight, hits an object. Objects don't just magically possess color. They interact with light by absorbing certain parts of it and reflecting others. The light that bounces off an object and reaches our eyes is what tells our brain what color we're seeing. So, why does iron oxide on Mars make it look red? It's because of the specific atoms and molecules that make up that iron-rich dust. These particles are like tiny light filters. They are very good at absorbing the blue and green wavelengths of light. When those blues and greens are absorbed, what's left to be reflected? You guessed it, the red wavelengths. That reflected red light is what travels across space to our eyes, painting Mars in our minds as the red planet. This principle applies to all the colors we see, from the blue of our own sky to the green of Earth's plants. We can actually demonstrate how light itself is a spectrum of colors. If you have a prism, or even just a glass of water placed carefully in a beam of sunlight, you can see sunlight broken down into all the colors of the rainbow. White light, the light we see every day, is actually a combination of all these different wavelengths. By seeing which wavelengths an object reflects, we understand its color. When handling a prism, remember to do so carefully. They can be a bit slippery, and we don't want any accidents. Sunlight works best for this demonstration, creating a beautiful display, but if sunlight isn't available, a strong flashlight in a dimly lit room can also work to show the spectrum. Can you think of other amazing natural events or phenomena where light interacts with tiny particles like dust or water droplets to create spectacular colors? Perhaps a rainbow after a storm, or the shimmer of a soap bubble. Share your brilliant ideas in the comments. Your observations help us all discover more about the world. While iron oxide gives Mars its signature red, the dazzling colors we see on other celestial bodies are often influenced by much more than just surface dust. Extreme conditions, like immense pressure and high temperatures found deep within planets or swirling in their upper atmospheres, play a significant role in shaping their vibrant appearances. It's a reminder that the universe is a dynamic place, constantly transforming. Consider the humble diamond. We often think of them as clear and brilliant, but diamonds can actually appear in a stunning array of colors. Blues, yellows, even pinks. These colors aren't random. They arise from tiny impurities trapped within the diamond's crystal structure, or from slight defects in how the atoms are arranged. These diamonds form under incredible heat and pressure deep within the Earth, proving that the conditions under which something is created profoundly impact its final appearance. We can explore the idea of different substances having distinct properties and how they might appear differently by thinking about cosmic ice in a simplified way. Imagine taking different common household liquids like plain water, cooking oil, and rubbing alcohol. If you pour each into a separate clear container, you can observe how they look different. Water is clear, oil might have a slight sheen, and rubbing alcohol can appear a bit cloudy or clear depending on its purity. While not exactly cosmic ice, this simple observation helps us visualize how different materials possess unique characteristics and appearances. A very important note for anyone thinking of trying this: adult supervision is absolutely crucial, especially when dealing with rubbing alcohol. It is flammable, and safety should always be our top priority. Never mix household chemicals without expert guidance and a clear understanding of what you are doing. Thinking about the materials around us, have you ever noticed anything change its color or appearance dramatically when it's heated up or put under pressure? Perhaps metal bending or food cooking? Share your observations in the comments below. It's through noticing these everyday transformations that we can better understand the grander processes happening in space. The colors we see when we look at planets are far more than just pretty sights. They act like cosmic fingerprints, providing scientists with incredibly important clues about what planets are made of, what their atmospheres are like, and even hints about their history. It's like being a detective, and the planet's color is one of the first pieces of evidence you examine. This detective work is especially crucial when we look beyond our own solar system to study exoplanets, planets orbiting distant stars. By analyzing the specific wavelengths of light that these faraway worlds reflect or emit, scientists can begin to understand the chemical makeup of their atmospheres. This is a key step in the search for potentially habitable worlds, as certain atmospheric compositions might hint at the presence of life. Imagine what we might discover. Think about how understanding colors enhances our appreciation for art or even just the beauty of nature around us. Similarly, delving into the science behind planetary colors unlocks deeper secrets of the universe. It's about connecting the very small, the behavior of atoms and molecules, with the very large, the majestic presence of entire planets. Each color tells a part of a grand, universal story. So, the next time you see a breathtaking image of a planet, whether it's Mars' rusty glow or Jupiter's vibrant stripes, take a moment to remember the chemistry and physics at play. You're not just looking at a picture, you're witnessing a story billions of years in the making, a narrative written in light and elements. What incredible space topic should we unravel next? Your curiosity is the fuel for our explorations. Drop your suggestions in the comments below, and let's keep this amazing journey of discovery going. Stay curious. And there you have it. You've journeyed from the familiar red of Mars to the vibrant, diverse colors of other planets, and you've uncovered the simple, yet powerful, chemistry that paints our solar system. We learned that Mars owes its rusty hue to iron oxide, essentially iron that has rusted over billions of years due to the interaction of oxygen with its iron-rich surface. And we saw how other worlds, like the gas giants Jupiter and the veiled Venus, display their own unique colors thanks to clouds made of different chemical compounds: ammonia, ammonium hydrosulfide, water ice, and even sulfuric acid. It all comes down to the fundamental principles of how light interacts with matter. Atoms and molecules absorb certain wavelengths of light and reflect others, and it's that reflected light that our eyes perceive as color. Whether it's the blue and green light absorbed by Martian iron or the complex mixtures creating Jupiter's bands, the science is elegant and consistent. Even extreme conditions like pressure and temperature can influence the final appearance of planets and celestial bodies, much like how the formation of a diamond under immense pressure gives it its unique color. It's a bit like building with Lego bricks. Each brick, whether it's a simple red one or a more complex blue one, has its own properties. But when you start connecting them, following the instructions, or even just experimenting, you can build something truly amazing and unique. Planets are the universe's ultimate Lego creations, built from the fundamental elements and guided by the laws of physics and chemistry. So, keep looking up at the night sky, fellow explorers. Keep asking those brilliant why and how questions. Your curiosity is the most powerful tool you have for uncovering the endless wonders of the cosmos. There's always more to discover, more to understand, and more to be amazed by. If you enjoyed this cosmic adventure and learned something new, please give this video a like and consider subscribing for more explorations into the incredible universe around us. Until next time, stay curious.